All right, so you're doing these 4 factoring problems. I am going to give you a little bit more time to work on them, but first let's take a look at that first one just to make sure we remember how it looks. In order to factor it, we say, what can I divide all 3 terms by? And so what can we divide all of them by? 5. And so we're going to be dividing everything through by 5. It's like distributive property backwards, so the 5 is going to end up outside of the parentheses. 15 divided by 5 is 3, so that gives us 3x to the 5th. Notice the x to the 5th doesn't change because we aren't doing anything with x's. We aren't pulling out x's or anything like that. 35 divided by 5 is 7, so that's going to be 7x cubed. Plus, then 55 divided by 5 is 11. Then just to double check that we have done it properly, we check inside the parentheses, 3, 7, 11. Is there anything that factors out of all of those? No. So that tells us we did in fact get the biggest thing factored out of everything. That's your final answer for number 1. Keep doing the same technique to finish the other 3. All right, so for number 2, we look to see what can I divide the 10, the 20, and the 12 by here, and all of them are divisible by 2. So we're going to pull the 2 out front of the parentheses. Then divide each of them that we had at the start by 2, so that gives us 5x squared plus 10x minus 6. Number 3, what can we divide all 3 terms by? 3. So I pull the 3 out front of the parentheses, so that gives us 2x squared minus 8x minus 5. And yes, that's the biggest we could factor out of everything there. And then let's take a look at number 4. Now, I want to show you something I saw in number 4, which is right but not completely right. And I want to show you how to deal with the situation, because it's going to happen. What if we said, hey, I can divide them all by 2? You end up with something that looks like that. But notice in this result here, we can still divide the stuff that's inside the parentheses by 2. When you see that inside your parentheses there's still something you can divide out, that tells you there was something bigger we could have divided out at the start. So when you see that, that's a way that you can know how to handle it. It tells you, okay, there's something bigger than 2. Look for it. It's 4 here. So instead we're going to factor out a 4, which leaves us with x squared plus 11x plus 10. All right, now we're going to be using this whole add 2, multiply 2 thing. We're going to be extending this into our other factoring skills here in a moment, but first we got to remember what these numbers give us. So for number 5, 2 numbers that add to 12 and multiply to 32. I start by thinking of all the different ways I can multiply to 32. And if you feel totally stuck on it, you can always make yourself a list of the different ways you can multiply to 32. That's basically it. We could also technically get the ones where they're all negative, but since we're adding to a positive, we know we don't need to worry about that. So which of those combinations adds to 12? Right there. The 4 and the 8. So that's our answer there. It's going to be 4 and 8. Or if you wrote it as 8 and 4, of course, still the same thing, perfectly fine. All right. Number 6. Same kind of an idea, except notice this time we're multiplying to a negative. If you multiply to a negative, that means one number has to be positive, one number has to be negative. So you think of all the different ways you can multiply to 18, and hopefully you see, hey, 2 and 9 are 7 apart. The question then is, which one has to be negative? And if we're going to add to a positive, that means we have to start with more positives than negatives, so that means the 9 must be positive, meaning the 2 is negative. Okay, number 7, all the different ways we can multiply to 40. Well, there's one that hopefully kind of leapt out to you. 5 times 8 is going to be 40. But 5 plus 8 is not negative 13, it's a positive 13. So in order to make it so that it'll add to a negative, but still multiply to a positive, we flip both signs. So it's got to be a negative 5 and a negative 8. And finally, for our 50, things that multiply to 50, 2 and 25, nope, not helpful. Let's see here, 5 and 10. That could be helpful. So let's use the 5 and the 10, because those are 5 apart. The question is, which one's positive and which one's negative? The 10's got to be negative. Because notice, since we're adding to a negative, we got to have more negatives than positives. All right. Make sure you have those written down correctly because they're going to be useful to you in a moment. So we're now going to look at how to factor these 4 problems. You actually have been doing all of the work needed to do it already. It's just now we see how do we apply it. All of those add 2, multiply 2 problems that we've been practicing for months have been getting you ready for this skill today. In order to factor number 9, notice it's a quadratic, but there's nothing I can divide out of every term. I'm going to put it into 2 sets of parentheses. Each one starts with an x, and then each one is going to be plus or minus some number. In this case, it's both plus. And we say what 2 numbers add to our middle number and multiply to our last number. So in this case, what 2 numbers add to 12 and multiply to 32? Well, you know this already, right? Because we just did that one. That was the very first add 2, multiply 2 problem we just did. It was 8 and 4. Now, it doesn't matter whether I write x plus 4, x plus 8, or if I write x plus 8, x plus 4. They both are the same, because it doesn't matter which order we multiply in. All right. Now, that is the factored form. I feel like I should prove it to you, though. So, this is the answer, but I now want to show you why that's the answer. If we wanted to multiply out our answer, we'd have to multiply everything in the first parentheses by everything in the second parentheses. And so, that would give us x times x is x squared. Then x times 8 is 8x. 4 times x is 4x. And 4 times 8 is 32. Notice I can combine like terms, x squared plus 12x plus 32. That's what we started with. Yes, it is the same. That whole add 2, multiply 2 thing that we've been practicing, notice where it comes from. The 4 and the 8, the 2 numbers that I was looking for, they multiplied to give me 32. And notice in the middle there, where does that middle number come from? We add the 4 and the 8. That's why the whole add 2, multiply 2 thing works. And so we can then factor a quadratic in a way that we can't factor anything else. So this is kind of a special rule here, a special case, where if it's a quadratic, we can factor it by using the add 2, multiply 2. So let's go ahead and do these adders here. So for number 10, I know since it's a quadratic, I'm going to end up with the 2 sets of parentheses. Each parenthesis will always start with x. Make sure you're writing these down in your paper as we go so you have them as examples. And in order to factor it, I need to figure out what 2 numbers add to the middle number and multiply to the last number. So what 2 numbers add to 7 and multiply to negative 18? Negative 2 and 9, absolutely. Which, again, that's what we did on the previous page, right? We did those for a reason, to make these a little easier. All right, so then, number 11. You've seen how this works. Take 10 seconds, write out what the factor form of number 11 will look like. So in order to factor it, we're saying what 2 numbers add to negative 13 and multiply to 40. Again, we did that one on the previous page. Remember that we got it was negative 5 and negative 8. So our factored form is x minus 5 times x minus 8. And finally, for number 12, write out what the factored form of that one would look like. you should be getting x plus 5 times x minus 10. Because again, the two numbers that add to negative 5 multiply to negative 50 were 5 and negative 10. Now the nice thing about these four is we had already done the work of the add to and multiply to. So you kind of look at the previous problems to see exactly what numbers you're going to plug in. You are, of course, going to have to be able to do it straight from the quadratic, though. So here's 4 more problems. Please write each of these in that factored form. Let's check and make sure you got the right idea here, especially with the first one, because sometimes this can throw people a little bit off when we say x squared plus x minus 12. So in this problem, what am I adding to? Because we add to the middle number, that is the number that's multiplied by x. What's that number here? Yeah, it's 1. So this one is saying what two numbers add to 1 and multiply to, what are we multiplying to here? Oh, not 12, negative 12. Keep track of that negative that's in front of it. Which is good, because it would only work if it was negative. If it was positive 12, this one would be impossible. All right, so then you can go ahead and factor it. So then what two numbers add to 1 multiply to negative 12? You hopefully are getting a positive 4 and a negative 3. So that's what number 13 would look like. Keep rolling with them. Okay, there's number 14 for you to check. So for 15 is actually a lot like number 13. Our two numbers have to be 1 apart. And so we end up with x minus 6 times x plus 5. Because we're adding to a negative 1 there. And in number 16, numbers that multiply to 24 and add to a negative 11. Well, most people, when we see them multiply to 24 and adding with the 11, are going to be coming up with 8 and 3 pretty quickly. But notice, since we're multiplying to a positive and we're adding to a negative, the only way that happens is if they're both minus. So they both have to be minus there, because a negative times a negative is a positive, but a negative plus a negative is a negative. We're going to do one more problem here. Remember earlier I had you factor this problem, 4x squared plus 44x plus 40, and we got this. Notice in this problem, it can actually still be factored using what we just learned. When you see a problem that looks like this, we start by factoring out that number from every single term to get this. But then once we have that, we can actually still factor this quadratic, the x squared plus 11x plus 10. We do that by figuring out what two numbers add to 11 and multiply to 10. Just like we were doing before. The fact that it's inside the parentheses doesn't change this technique. And so when we factor it out, that 4 that we had at the start, it stays there. Then the two numbers that add to 11 and multiply to 10, you should be getting 10 and 1. And so notice what that factor form ends up looking like. We end up with 4 times x plus 10 times x plus 1. So we can actually now combine those factoring techniques that we know. I do want you to practice these types of problems. I'm just going to give you 2 of them. We don't need to do a ton of them. Factor these 2. These are the last problems we're doing together today. When doing this one, we need to start by factoring out the number that I can divide them all by. In the case of number 17, that's the 5. So we're going to go 5 parentheses. And then 5x squared divided by 5 is x squared. Some of you are writing 1x squared. Same thing. Just realize 1x squared is x squared. Minus stays the same. 30 divided by 5 is 6, so that's going to be a 6x. Minus 35 divided by 5, which is 7. Having done that, I now need to see how that factors. So I'm saying what two numbers now add to negative 6 and multiply to negative 7. And yes, something does multiply to negative 7 itself and 1, right? There's always the number itself and 1 as an option. And in this case, that will help because we get a negative 7 and a positive 1. So that's the final answer. Yes, you do need to show both of those steps. If you leave this step out and don't write it down and try to do it without it, you'll actually cause yourself to take more time, and it's a lot harder. And I can tell you it's fraught with errors. I will even make mistakes if I try to do it that way. I have to write it out. So, make sure you're writing out all the steps. Number 18. We first look to see, can I divide everything by the same number? And I can divide them all by 2. So that leaves me with x squared plus 14x plus 45.
Divided by 2 is what?
Then, I now look inside the parentheses and see what two numbers add to 14 and multiply to 45. And yes, it is possible. It ends up giving us 5 and 9. And so there is the totally factored form for number 18.